Okay, we're going to do problems 106, part B, 107, 108, and 109. So we've got a lot. Um, sorry. So 106, part B looks like this. The first thing we'll do is factor, and that means we have to set up our generic rectangle. So they'll multiply to be negative 18x squared. They have to add to be 17x. I hope you're very used to this process. That'd be 18 and negative 1. So we can put our 18x and our negative 1 anywhere you want. Out of the top comes 3x and x, 6, and negative 1. So our factoring will be x plus 6, 3x minus 1. I know I did that a little fast, but I think we're pretty good at factoring now. So here x plus 6 equals 0, so x equals negative 6. That's one answer. Or over here, 3x minus 1 equals 0, so 3x equals 1, x is a third. And remember that this step right here that I'm putting in red, that's true because of the zero product property. Okay, 107 is actually problem 106 part B done again. And the basic idea here is we're going to use the quadratic formula just to prove that we can use it for any problem. So A is 3 because it's the coefficient of x squared. B is 17, it's the coefficient of x. C is negative 6. So it'll be x equals the opposite of B plus or minus, and this could get ugly, square root b squared, that'll be 17 squared, minus 4, 4 is always there, times a times c, all over 2a. So that's the general setup, and then we're just going to continue this process through. So 17 squared is 289, 24, that'd be 72. Uh-oh, and now the numbers are getting big. I should have grabbed a calculator. Okay, 17 plus or minus, let's see, it's 361. Okay, no calculator, no calculator. And square root of 361 is 19. I hope all of you are thoroughly impressed. And then we do the positive and the negative side. So up top it'll be negative 17 plus 19, that's 2 over 6, so that's a third. And on the bottom it'll be negative 17 minus 19, that'll be negative 36 over 6, which is negative 6. Sorry, I ran out of room. Okay, next one is 108. I thought this one might be a little strange looking to you. So the parabola, which is obviously terribly drawn, has roots at negative 3 and at positive 1. So it should be easy. Negative 3 means it has to be x plus 3, because that negative 3 will be a solution to that, and the other one would have to be x minus 1. Multiply that out using a generic rectangle. I'm not going to write that down. I hope you do for your homework, but this would be it if you multiplied it out. Okay, on part B, I didn't copy the whole table, but I copied the important parts. The first one, or the first two, where I'm drawing arrows, those are roots. So we need to have x plus 2 in parentheses and x minus 2 in parentheses. And when you multiply them, they have to equal 0. Okay, so when you multiply that out, you get x squared minus 4, and you can generic rectangle that out. And it's got to be a parabola, a general parabola, so we want it to be y equals, so that it's not just finding the roots, and that's our equation. Okay, now if somebody tomorrow, the first person who comes in and says something to me to tell me why I didn't do anything with this, but it does still fit the problem, if you can explain what's going on with this, I'll give you a couple of extra points on your homework assignment. Okay, 109. This is the one where it says the length of a rectangle, blah, blah, blah. The first thing I would do is the length of the rectangle is 5 centimeters longer than twice the width. Remember, each sentence can be translated into an equation. So the length of the rectangle, length is 5 longer, that's going to be 5 plus, than twice the width. Okay, so that's our length equation. The second one says the area is 403 square centimeters. Well, let's think here. Area, isn't area off to the side? Area is just equal to length times width. So, for our equation here, if we said length width equals 403, now we can solve this equation. We're not used to solving these two things when they're stuck together like this, but it's really not a big deal. All we're going to do is take our L up here. We're going to use the substitution method, taking our length, 5 plus 2w, and we're just going to plug it right in there. Okay, what makes this a little hard is the fact that we're going to have w's kind of everywhere in this equation. Not only that, but when you distribute this thing out, it's going to have a square in it. Okay, I'm not going to do all this out, but what I do want to do is call your attention to that 2 right there. 2 is obviously really important because that makes it a quadratic equation. So if I reorder it, it'll be 2w squared plus 5w equals 403. And now remember, we don't solve quadratic equations unless it equals 0. So we move everything over to the left side. And I'll do that by subtracting 403 on both sides. And we get this. Now, you can use the quadratic formula on that. Okay? And Hot Math, I'm sure, has all the numbers worked out, but you can use a quadratic formula there. And that should be that. Okay, see you tomorrow. Bye.